Hey guys, welcome back. Houston Math Prep here. In this video, we're going to talk about a couple of different things with fractions. We're going to look at how to tell if fractions are equivalent, how can we simplify fractions, and how can we put fractions in numerical order. So let's begin by talking about equivalent fractions. So we can say that two fractions are equivalent if the rational numbers that they represent are equal to one another. There are actually several different ways to determine this equivalence for two fractions. Let's take a look. One of the first ways that we can determine if two fractions are equal is to look at them visually. So here's what we mean by that. Let's take a rectangle, or really you could do this with any shape. And let's say we want to model 1/2. So we break this rectangle into two equal pieces because the denominator of 1/2 is 2, and then we shade one of them. So here is 1/2. Now, if we wanted to think about some fractions that are equivalent to 1/2, let's say that we take that same rectangle, and now instead of having it broken into two equal pieces, we break it into 4 equal pieces. Then the question is, how many of those 4 equal pieces would need to be shaded to have the same area shaded as 1/2? Well, 2 of them, right? 2 of those equal pieces here would be the same as 1 equal piece before. That tells us that 2/4 and 1/2 are equivalent fractions. We could continue this process, taking that same shape that is currently broken into 4 equal pieces, now breaking it into 8 equal pieces. How many of those 8 equal pieces would need to be shaded to have the same area as 1/2 or 2/4? Well, for that we would need to shade 4 out of those 8 equal pieces. So therefore, 4/8, 2/4, and 1/2 are all equivalent fractions. Another way that we can tell if fractions are equivalent is using their simplest form. So a fraction, a over b, is in its simplest form whenever the greatest common divisor, or GCD, of the numerator and denominator is equal to 1. Another way of saying that is that a fraction is in simplest form when its numerator and denominator are relatively prime. So two fractions are equivalent if their simplest forms are equal. So let's take 10 over 12 and 20 over 24. If we want to determine whether these two fractions are equal, we want to get both of them down to their simplest forms and compare those. Now, how do we simplify fractions? Well, first we ask ourselves, is the fraction already in simplest form? Is the greatest common divisor of 10 and 12 1? Well, since both of them are even, we know that that is not the case. They at least share a 2. So if we take 10 and 12 and we get their prime factorizations, 10 can be broken down to 2 times 5, and 12 can be broken down to 2 times 2 times 3. Then any factor that the numerator and denominator share can be canceled. So here, one factor of 2 can be canceled from the numerator and the denominator, meaning that our simplest form for 10 over 12 is 5 over 6. Now, if we use the same procedure for 20 over 24, here are our prime factorizations, and you can notice in this case that both the numerator and the denominator each have 2 copies of 2. If we go ahead and cancel those out, we are again left with 5 over 6. Because the simplest form for these two fractions are the same, then 10/12 and 20/24 are equivalent fractions. Another way that we can tell whether two fractions are the same is to get a common denominator. So two fractions are equivalent if their numerators are equal when they have a common denominator. This fact comes from the fact that when we get a common denominator, what we are doing is making both fractions have the same size piece. So if we make the denominator the same, remember the denominator tells us how many equal sized pieces make a whole. So when two fractions have a common denominator, they are working with the same size pieces. If we then compare how many of those equal pieces we have, Well, they would need to be the same in order to be equivalent. So let's take 15 over 7 and 30 over 21 as an example. We can find a common denominator for two fractions by finding the least common multiple, or LCM, of those denominators. For 7 and 21, our LCM is 21. So to take 15 over 7 and give it a denominator of 21, we'll need to multiply both the numerator and the denominator by 3, because 7 times 3 makes 21. When we do that, we get an equivalent fraction to 15 over 7 of 45 over 21. Now 30 over 21 already has the denominator of 21 that we need, so we can think about multiplying it by 1 over 1. Now that our two fractions have a common denominator, or they're now working with equal-sized pieces, we can see that our numerators, 45 and 30, are not equal. That means that the fractions 15 over 7 and 30 over 21 are not equivalent fractions. A third way to tell whether or not two fractions are equivalent actually just comes from a shortcut of our previous method. We have what is called the diagonal product that says that two fractions, a over b and c over d, are equivalent if the product a times d is equal to b times c. Now that may seem a little bit arbitrary, but if we think about our common denominator that we would need to get between those two fractions, that common denominator would be b times d. Well, a over b with a denominator of bd is ad over bd. And c over d with a denominator of bd is b times c over b times d. So if we compare our numerators, now that we have a common denominator, we can see that these two fractions will only be the same if their numerators, ad, is equal to bc. So let's take this method and play around with it a bit. Let's say we have 8 over 6, and we want to know if that is equal to 36 over 27. So we can take what is called our diagonal product, or the product of the diagonals. So let's start with the product of this diagonal, 8 and 27. Well, 8 times 27 is 216. If we compare that with the product of our other diagonal, 6 and 36, 6 times 36 equals 216. So now when we compare those two values, we see that they are equal. 216 equals 216, which tells us that, in fact, our fractions, 8/6 and 36/27 are equal. This diagonal product comes in handy because we can also use it to order fractions. We have the property that a over b will be greater than c over d if and only if AD is greater than BC. Now this comes from that same shortcut on common denominators. Remember, if we make the denominators equal, then we make the pieces the same size. So certainly if if we have more pieces in one fraction than in the other, then AD will be greater than BC, and therefore A over B will be greater than C over D. So let's test it out. Let's say we want to figure out which is larger, 7 over 8 or 5 over 6. Well, we can check out our diagonal products. Looking at the product of 7 and 6, 7 times 6 is 42. And looking at the product of 8 and 5, 8 times 5 is 40. Now we know that 42 is greater than 40, so therefore the fraction with 42 over it, 7/8, is greater than 5/6. We can also do this with negative fractions, but we need to be careful with our placement of greater than or less than symbols. So let's compare -5/12 and -2/9. Looking at our diagonal product, we have -5 times 9, which is -45, and then we have 12 times -2, or -24. Remember that a negative number with a larger absolute value is smaller because it is further away from 0. So in this case, negative 24 is larger than negative 45. That tells us that in this case, negative 5 over 12 is less than negative 2 over 9. Alright guys, that does it for this video on equivalent fractions, simplifying fractions, and ordering fractions. Until next time, we'll catch you in a future video.